Let us now see how we apply the formula for the correlation coefficient. Let's first recall that the disadvantage of the covariance is that it is unit dependent. Right? So ideally for us, what we want to have is we want a statistic that is not affected by how the variables are measured. Right? Okay. If we have such a statistic, then we can use it to compare the strengths of linear relationships between different pairs of variables. I will show you now that the correlation coefficient gives us exactly what we want. So what I have here is the same data set we used to calculate the covariance. Right? Remember that we got 0.2867 for the covariance between time measured in hours and GPA. If we want to compute the sample correlation coefficient, we want to divide the sample covariance by the product of the sample standard deviations, which were given to us in the original problem, right? So the sample standard deviation of time is 1.0116, and then the sample standard deviation of GPA is 0.2944. So if you plug these numbers into your formula and do the math, the correlation coefficient is equal to 0.9626. Now, we said that the relationship should be the same if we measure time in minutes. Right? But when we calculated the covariance between time measured in minutes and GPA, we got 17.2 as the answer. Let's now compute the correlation coefficient though. If you compute the correlation coefficient, you want to divide the sample covariance by the product of the standard deviations. Okay. So the sample standard deviation of time is 60.6960, and the sample standard deviation of GPA is 0.2944. So if you do the math, you would get 0.9626 for the correlation coefficient, which is the same as the correlation, so same as the correlation coefficient between time in hours and GPA. So the correlation coefficient can be used to compare the strength of the relationship between different pairs of variables. So what did we do in this video? In this video, we looked at how we apply the formula to calculate the sample correlation coefficient Rxy. Right? And then we showed that we get the same correlation coefficient for time measured in hours and GPA, and time measured in minutes and GPA. And so the correlation coefficient can be used to compare the strength of the linear relationships between different pairs of variables.